the ball going up and down. Is that the first question we're looking at?
Yeah, golf ball. Straight
Golf
up and
ball.
down.
Yeah, so this probably shouldn't be too bad, right? So I always like to draw a picture of the physical situation. But if we've got a person sort of throwing it up and down, they're standing on top of a building. Ball one is going upwards, and then ball two is sort of going downwards, right? A golf ball is thrown straight up from the edge. A second golf ball is dropped at a time 1.19 seconds later. And we are asked what the initial speed of the first ball is if they hit the ground at the same time. Okay, so we do know the distance of the we do know the height of the building, I should say, rather. And if this is B1 and this is B2, the idea here is that we can just sort of write out the equations, right? I'm trying to think about how I'm hoping to develop a better flow as we go along, but I'm hoping for a problem like this, I can just go ahead and sort of define the variables as we go, because I don't think this one is too involved. But I'm just using the kinematic equation to express the distance, change in distance with respect to velocity, time, and acceleration. But 1/2 g t1 squared, right? This is basically saying the ball one will have a total net change of minus h, right? Because it's going up and then coming all the way back down. So at the very end, it's going to decrease in height by h. So then velocity initial of ball one is something that we don't know yet. And we also have t1, which is the time the ball one is traveling in the air. Okay, so far so good.
Quick question.
What's up?
How would you like out of the other four kinematic equations, why this one just like off the
Yeah,
bat?
no, it's that's a reasonable question, and maybe I should sort of run the session by keeping all four kinematic equations up in a corner somewhere to just always refer to. But with something like this, you gotta try like writing them out a little bit. Um, how do you put it? We're not too interested, like we're not too interested in the other equations like vf squared minus v naught squared is equal to 2ax. Some of this seems reasonable, but the VF, it just doesn't seem like we're terribly interested in it for what we're being asked to do. Now, chances are, because a lot of these are very interrelated, we probably could have done the problem with VF, but I'm going to write it out this way because, well, just sort of matching variables, it seems like we either know everything about these two, except for the two unknowns, which is exactly what we're trying to find. But for the other one, like velocity naught of ball two is just 0, right? And the time is going to be, let's call it t2 is the amount of time it's traveling. G t2 squared. And we do know that t2 is equal to t1 minus, I think the number is different from everybody, but it's like, 1.1 seconds or something, right? Not a big deal. But the point is, t1 is an unknown, but t2 is sort of an unknown, but it's really just t1 in disguise. So this set of two equations has just these two unknowns, velocity naught of b1 and t1. And as always, I will let you do the solving on your own, but at this point we have a system of, I'll say it again, two equations and two unknowns, which is totally solvable. Do you all agree?
Yeah.
Yeah, very good. So then it's asking for what must be the initial speed of the ball if both are to hit the ground at the same time. Well, yeah, that basically means it's just looking for this one, right? Yeah, choosing the right kinematic equation is, I guess at this stage it's kind of more of an art than a science, but more or less just look at what things you do know and look at your four kinematic equations and try to see if you can get some good alignment going on between the variables you're looking for and the variables you do know and what the equations themselves are, right? So just to remind you, this equation I love to use, but it just seems like VF is kind of irrelevant to our problem, which is why I kind of shied against it. Okay. Oh, right. This is for B2. And now it says, consider the same situation But now let the initial speed v naught of the first ball be given, and treat the height h of the building as an unknown. Okay. Sure, why not? So, just in my silly little notation, I guess a straight line means that something is known, and a squiggle means that something is unknown. So I'll put a squiggle under h. So it's what is the height of the buildings must be for both balls to reach the ground at the same time for some given velocity. Well, okay, it changes the problem a tiny bit, but fundamentally it's still two equations and two unknowns. So just solve, right? Once you have the system of equations set up and all the variables nice and in place, it really shouldn't be too bad to just go plug things in and solve them as if it was just a high school algebra course. I'll write this just a tiny bit more explicitly, but T2 is just T1 minus 1.1 or whatever it is for your specific problem. Okay, I think that's the first problem. Any questions about it?
So for the first equation, we'll have to have it so that it'll be b initial equals an equation which comes out to a number.
I'm sorry, say that again. The first equation, what?
Oh, for B1, for ball one, as in for problem one, it'll initially be VI, as in V initial equals an equation which comes out to a number.
I'm not quite following what you're talking about, Rand. Is that what you're trying to? Are you saying that's what you're trying to solve for?
Yeah, VI.
Yeah, I guess you could do it that way. How would I think about it? So okay, for part A, basically, right, where height is known and velocity initial is unknown. How would I do this? I would probably start by solving the second equation, and solving T2, or rather T1, in terms of h. So then once you know T1, you would just plug it in here, and here, and then you would solve for V naught. Does that approach make sense?
Yeah.
I think you were kind of proposing the other way with solving V naught first, if I'm not mistaken.
Yeah.
And I guess that's doable. Yeah, I mean, you could solve for V naught in terms of T1, and then plug V naught in terms of T1. Well, the issue is, yeah, okay. You could solve for V naught in terms of T1, and then I guess you could plug that into the second equation for T1, and that would let you solve, then everything would be in terms of V naught, and then I guess you could solve it that way. I think it's a little bit confusing, but it should be doable. But either way is fine. Fundamentally, two equations, two unknowns. Nothing is more than a quadratic, so this should be perfectly solvable. Cool?
Yeah.
Okay. Any other feedback from anybody else before we move on?
Yeah, I have a question.
What's up?
So V naught minus B1 is just one number.
Oh, sorry. This is like an underbar. This is all like subscripts. This is like
Oh,
V
okay.
naught, like an underline B1, because
Oh, okay.
V naught underline B2 is also sort of a quantity in this problem. It just happens to be 0, which is why I crossed it out over here.
Oh, okay.
Gotcha.
Got it.
Thank you. Sorry. For things like my handwriting or notation or something, please speak up as soon as you have a question. Please do. Yeah, I think that's the benefit of having students ask things live, is just to clarify stuff like that I'm sure someone else is also going to wonder about. But cool. Okay, I guess we're moving
Yes,
on.
thank you.
Of course. Yeah, and I'll try to make these, go quicker and quicker as I get more into the flow of it. But thanks for sticking with me for this sort of proof of concept.